Welcome to the Day Talk Show hosted by Mary Williams. Today on our show, we are lucky enough to have Michael Deacon, the writer of Hypatia and Her Mathematics. How much do you know about the mathematician Hypatia? Through your research, what did you discover about Hypatia's life?
Interestingly enough, Hypatia was the first known woman mathematician along with being a well-respected philosopher. Her work expands into the origins of geometry, which she learned from her father who was also a well-known mathematician. While she was a great mathematician, the most well-known aspect of her life was her death. There is some controversy surrounding the time and events of her death, but it's believed she died by the means of stripping, dismemberment, and burning by a Christian lynch mob because of her being a well-known public figure who was not Christian.
That sounds traumatic. I wouldn't want to be remembered for my death.
While not much is known about her work and the information credited to her is still questioned today, she is thought to have contributed significantly to mathematics. While only 3 books are known to have been written by Hypatia, her impact has been long-standing in the fields of astronomy and geometry. In astronomy specifically, she worked on such ideas as the astronomical canon, which is a calendar that measures time by star movement and placement, and astronomical tables, which describes all the phases of the moon based on the time of year.
You mentioned Hypatia was involved in the field of geometry. What were her contributions there?
Her main achievement was her research on conics, which include hyperbolas, ellipses, and parabolas. All 3 examples of conics are created from the cone, but each is created from a different plane angle slicing the cone. Hypatia wanted to understand how a plane sliced a cone to form different functions and shapes.
I hear Hypatia published 2 equations. Can you tell me more about those?
The equations she wrote specify if there are a certain amount of variables, you can solve the equation. Before the show started, I wrote the equations on the board for reference. The main point of these equations was to show the amount of information you will need to solve it.
I remember how much I enjoyed my Calculus 1 class in college. What information did she contribute to the field of calculus?
As I mentioned previously, Hypatia spent a lot of her time with conics. These ideas are not as common as others in the field, but it is an important step towards understanding the field as a whole. Other than conics, she worked on the equations you see on the board, but these relate more to algebra than calculus. The equations are a stepping stone to understanding the complex topics in calculus.
How were Hypatia's contributions used?
In the past, she contributed to navigation within the shipping industry as westward expansion took place. Her inventions were an instrumental part to safely and accurately navigating the waterways of both the known and unknown world. Also, Hypatia's equations played an essential part in the field growing into what is commonly known today as mathematics. The only real concept still consistently used today is her research on conics.
Looking back on your research of Hypatia's life, is there anything you would have done differently?
One change I would make is to simplify the language of the paper to reach a broader audience base. Another change would be to better explain the 2 equations in the paper to point out how simple they actually are. Even though the equations are simple in today's time, Hypatia put a lot of time and effort into writing the equations.
What are some practical applications a common student could apply the research into their lives?
One aspect that could be used is in the case of navigation when compasses do not work in iron-rich environments. Iron is highly magnetic, which throws off the true north and south magnetic fields of the Earth. Compasses rely on this magnetic field to show the directions. The only downside of using an astrolabe is its reliance on weather and the need for stars to be visible. The main reason for me writing this article is to show the world Hypatia's contributions and how unknown she is. I really wanted historians to see the true light of Hypatia.
Thank you so much, Michael Deacon, for coming on the show today. Thanks to your excellent research, the audience and I have a greater understanding of where conics come from. I always assumed they were random shapes. Who knew? Like a spider web, math topics are all related and build on each other. Please tune in for our show tomorrow when our guest will be Robert Downey Jr. Stay classy, Eau Claire.